Hi everyone. Yesterday I created a video where I took you through creating the histogram and working with this data in a manner to be able to get it ready to do the means and standard deviation part of this assignment. So today I'm going to go through the rest of the week 2 individual assignment and all the different steps so that you have some sort of an idea about how to go about doing this. So the first thing we need is the X bar, and X bar, all that means is the average. So in order to get the average in Excel, what I am going to do is here I'm going to do an equal sign, and I'm going to start typing the word average, and there's the average. Yay! So I'll click on that, double click on it rather, and I'm going to highlight the high temp from the top all the way down to the bottom and close off the parentheses. So now what you see here is equals average and open parentheses C2 colon C61 end parentheses. That is my formula that's in this cell right here. So my average temperature for my data is 68.4 degrees. Then what I want to do is get a standard deviation, and since this is not a population, this is a sample of just 60 days for Seattle, I want to do a standard deviation of a sample. Now, there are more complicated ways of doing this, but this is the fastest way to do it, and so let me show you how that works. So I type the equal sign again, and I'm going to type STD, and there we go. We have the standard deviation of a sample right there. So I double click that. I highlight the same number range from C2 to C61, close parentheses. Alright, now what I have here now as a formula is equals standard deviation of a sample, open parentheses, and my range of numbers, closed parentheses. So that's the formula for that. Now, so my standard deviation is 9 degrees, just slightly over 9 degrees. So I've already put formulas in here. So that was step 3. Step 4 is to take that mean and add or subtract 1 standard deviation. Okay, so my mean of, or my average, my mean of 68.4 minus the 1 standard deviation of 9.022, that gives me 59.377. And then I take my mean as well, and I add 1 standard deviation, and that gives me 77.422. Now, in my data, and this is my data set, yours may be different. In mine, I want to actually look at what my range points are here. And so 59.377, I don't have any temperatures that I recorded or put in the spreadsheet that have decimals. So in this case, I would not be able to include 59 degrees because 59 is below that mean minus 1 standard deviation. So I have to go with 60 degrees to 77 degrees. So that is my range. Now, this is in order to get the percentage of my data points that actually fall in 1 standard deviation, okay? So 60 to 77 degrees. So here's 77 degrees, and if I highlight all the way down to 60, because I've kept my data sorted, I have 34, so right down here you see 34, I have 34 data points that fall within that 1 standard deviation. So I'm going to type 34 there. This formula is actually taking 34 and dividing it by 60. So that gives me 56.67% of my data points actually fall in that 1 standard deviation. Now we're doing the same thing again in step 5, where we're doing this same calculation, but we're doing it for 2 standard deviations. So what that means is the 9.022 is multiplied by 2 for 2 standard deviations. All right, so the 68.4 degrees minus 18.044, that gives me 50 degrees 0.355, as you see there. And then the mean of 68.4 degrees plus 18.044, that gives me 86.44 degrees. So my range, what is my range? My range is now 51 degrees to 86 degrees. So now let me find how many of my data points fall in 2 standard deviations. So I come over here, and 84 falls in my range, but 87 doesn't. So I'm going to start with the 84, go all the way down, and my lowest high is 55 degrees. So there's quite a bit of my data falls in that 2 standard deviation range. So the count of that is 58. So I come back here, type the 58, and that tells me that 96.67% of my data points fall within 2 standard deviations. Now, when you look at the rest of the steps, it's asking you, okay, so for 1 standard deviation, a typical data set, if it's normally distributed, will have 90+% that fall, in a certain range. And so my data is not exactly perfectly distributed, but it comes pretty darn close. And that's what this exercise is all about. So if you have any questions about this or any of the calculations, hopefully this gets you some strong footing on how to do this and how to kind of wrap your head around it. Just please leave me a question. You can private message me or call me, either way. So I hope this helps, and I'll see you again soon. Thank you.